Okay, let's dive in. The sun. It's been putting on quite a show lately, hasn't it?
It really has. We've seen a whole series of powerful events, multiple M-class flares, and even some significant X-class ones.
And the immediate impact. We've seen these widespread radio blackouts. Huge areas affected North and South America, Europe, Africa, the Middle East, even Southeast Asia.
Yeah, and what's happening there fundamentally is just this immense release of energy. Solar flares are, sudden bursts of electromagnetic radiation.
Right?
So they come from these areas on the sun with super intense magnetic fields, usually around sunspots.
Like tangled magnetic bands snapping.
Exactly. That's a great way to put it. The magnetic field lines get twisted and tangled, build up tension, and then bang, they reconnect explosively. All that stored energy gets released as a flare.
And it's been, well, pretty busy up there. Tuesday, May 13th, we had that X1.2 class flare from sunspot AR4086. Then early Wednesday, May 14th, a different sunspot AR4087. It just kicked things up a notch.
It really did. First, an M5.3 flare.
Then boom, a much stronger X2.7 flare.
And it wasn't done. A few hours later, an M7.7 flare, just to, keep us on our toes.
So maybe we should quickly touch on how these are classified, these letters and numbers.
Right. Yeah, it's important. Scientists use a letter system, A, B, C, M, and X. It ranks the flares based on their peak X-ray brightness.
And it's not a linear scale, is it?
No, not at all. Each letter represents a 10-fold increase in energy output. So M is 10 times stronger than C, and X is 10 times stronger than M. Big jumps.
Okay, and the number after the letter, like X1.2 versus X2.7.
That just gives a finer scale within the class. So an X2 is stronger than an X1, and M9 is much more powerful than an M1, and so on.
So these recent ones, the X1.2 and X2.7, they're in the top tier X class, but actually sort of on the lower end of that X range.
That's right. For perspective, the biggest flare we've seen in the last 7 years or so was an X9 back in October 2024. So these are significant, definitely, but not off the charts huge compared to the absolute maximum possible.
Still, X-class flares are the most powerful category.
Absolutely. And these are the first ones we've had since March this year. It definitely signals a ramp up in solar activity.
Okay, so the mission for this deep dive is really to understand what this all means. The impacts of these flares, what else might be associated with them, and what might be coming next.
Sounds like a plan.
So let's start with those impacts we've already seen. The radio blackouts. You said it's the radiation from the flares causing this. How does that work exactly?
Okay, so the flare erupts, right? It sends out this intense burst of X-rays and extreme ultraviolet radiation. This travels at the speed of light.
Reaches us in about 8 minutes.
Exactly. Now, normally, things like shortwave radio signals, the kind used for, say, long-distance communication by ships or planes, they bounce off a layer in our upper atmosphere, the ionosphere.
Okay.
But the intense radiation from a flare hits the lower part of that ionosphere, the D layer, and it drastically increases the ionization there. It basically creates many more charged particles.
And that's bad for radio waves.
It is for the high-frequency ones, yeah. Instead of bouncing off cleanly, this super ionized D layer absorbs them. So imagine your radio mirror suddenly becomes like a thick fog.
So the signal just gets lost, swallowed up.
Pretty much, yeah, especially across the entire sunlit side of the Earth, because
Right.
that's where the radiation hits.
Which explains why it affects mariners, aviators. Even satellite navigation can get a bit wonky.
Precisely. Communication goes down, navigation accuracy can degrade. It has real-world consequences.
You wonder about knock-on effects, too, with global logistics relying so much on that kind of communication and timing.
That's a valid point, definitely.
Okay, so flares are one piece, fast radiation, immediate radio impacts. But I always hear about CMEs, too. Coronal mass ejections? Are they the same thing?
Good question. No, they're different, though often related. A flare is a burst of light and radiation. A CME, a coronal mass ejection, is an actual massive explosion of physical stuff from the sun. Yeah, solar plasma, superheated, electrically charged gas and magnetic field, blown out from the sun's outer atmosphere, the corona. Think of it like a giant magnetic bubble filled with solar particles erupting outwards.
Okay, a huge bubble of plasma, and they often happen with flares.
Often, but not always. You can have flares without CMEs, and sometimes CMEs without obvious flares. But powerful flares, especially X-class ones, are very often accompanied by CMEs.
And how do these CMEs affect us compared to the flares? You said flares are light speed, 8 minutes, CMEs.
Much, much slower. They're actual clouds of particles, so they travel at, well, Typical solar wind speeds, maybe a bit faster after an eruption, hundreds, maybe a few thousand kilometers per second.
So not 8 minutes, more like...
Hours to days. It can take anywhere from, say, 18 hours to maybe 4 or 5 days for a CME to cross the space between the sun and Earth.
Okay, so we do get some warning time if one's headed our way.
We do, yes. Space weather agencies track them.
So what happens if one does hit Earth? If this plasma cloud slams into us?
Right, so when that cloud of charged particles and magnetic field arrives, it interacts with Earth's own magnetic field, our magnetosphere, and our upper atmosphere. This whole interaction, this disturbance, is what we call a geomagnetic storm.
Geomagnetic storm. And the most famous effect is?
The auroras, the northern and southern lights. During a geomagnetic storm, the auroras can become much brighter and spread much further from the poles than usual.
That's the beautiful part. Is there a less beautiful part?
Yes. Strong geomagnetic storms can do more than just light up the sky. They can induce electrical currents in power lines on the ground.
Induce currents, like phantom electricity?
Sort of, yeah. Geomagnetically induced currents, or GICs. If they're strong enough, they can overload transformers and potentially cause large-scale power grid disruptions, even blackouts.
Wow. Okay. Anything else?
They can also affect satellite operations. Increased drag can alter orbits, and the charged particles can damage electronics, and GPS signals have to travel through that disturbed ionosphere, so accuracy can suffer again.
So there must be a scale for these storms, too, like the flare scale.
There is. NOAA uses the G scale for geomagnetic storm intensity. It goes from G1, which is minor, up to G5, which is extreme.
And G5 is bad.
G5 is the big one. We're talking potential for auroras visible as far south as Florida or southern Texas. And, critically, the potential for widespread voltage control problems and grid collapse, damaged transformers, serious infrastructure impacts.
Okay, that puts it in perspective. So back to these recent flares, the X2.7 in particular. Did that one launch a CME? And is it coming our way? Should we be bracing for a G-something storm?
Well, this is where things get really interesting right now. Yes, the X2.7 flare absolutely launched a CME. A big one, probably.
Since a but.
But because of where sunspot AR4-87 was located when it erupted right on the sun's northeastern limb, basically the edge from our point of view.
Ah, so not pointed at us.
Exactly. It's like the cannon wasn't aimed at Earth. This CME, and probably any others from that spot's recent activity, are heading out into space, but not towards us.
Phew. Okay. Where's it going, then?
Well, models from NASA actually predict it's heading towards Mars. It's expected to arrive there around Sunday, May 18th.
Mars. Seriously. So Mars might get auroras from this.
It's possible. Mars has a very thin atmosphere and no global magnetic field like Earth. But it does have localized magnetic fields. It could potentially trigger some weak auroral displays there. Fascinating to think about.
That is incredible. Does watching that happen on Mars teach us anything useful?
Oh, definitely. Studying how these events impact other planets, especially one like Mars, without a strong global shield, helps us understand planetary atmospheres and space weather effects in general. It gives us comparison points.
Okay, so Mars gets the light show. We dodged the bullet for now. But you said the sunspot was on the edge. The sun rotates.
Precisely. That's the crucial next part of the story. The sun rotates roughly every 27 days. So over the next week or so, sunspot AR4087 is going to rotate across the face of the sun as seen from Earth.
Meaning it will eventually be pointing right at us.
It will indeed move into a position where Earth is directly in its line of fire, so to speak.
Okay, so if it stays active.
If it stays as magnetically complex and active as it is now and continues to produce flares, then yes, we could certainly see more of those radio blackouts affecting Earth directly.
And if it fires off another CME when it's facing us?
Then that CME would be Earth-directed. And depending on its size and speed, we could be looking at a geomagnetic storm here, G1, G2, maybe higher, with those potential impacts on power grids, satellites, and definitely more widespread auroras.
Right, so the near miss was good, but the potential threat is actually increasing over the next few days as it turns towards us.
That sums it up perfectly.
So what are the official forecasts saying? What are the space weather folks at NOAA predicting for, say, the next 3 days through Friday, May 17th?
Well, they're definitely watching Region 4087 closely. The forecast reflects that potential. They're stating there's a high chance of M-class flares continuing. Specifically, they've put a 65% chance on further M-class flares through the 17th.
65%? That's pretty high. What about X-class?
They're giving it a 30% chance for X-class flares during that same period.
Yeah.
Also quite significant given the magnetic complexity they're seeing in that sunspot region.
Okay, so a high chance of more M flares causing radio issues, and a not insignificant chance of another X flare, which could also bring a CME, potentially Earth-directed this time.
That's the situation. Yes, the next few days are definitely a period to watch closely.
It really does make you think, doesn't it? Seeing this activity ramp up, understanding the potential impacts, how much we rely on technology that's potentially vulnerable to these huge solar events.
It absolutely does. And perhaps that leaves us, and you listening, with a question to ponder. As this active region turns towards us, and given our growing dependence on technology, what are the broader implications of this kind of solar activity? And, what sort of preparations, if any, might be worth considering, both personally and maybe on a larger scale?
Definitely food for thought. We'll certainly be keeping an eye on the sun.